Continue our discussion about circle geometry. Uh, Here you have circle geometry. As I told you earlier, circle geometry is very simple. You only follow some theorem and principle. Once you mind those theorems as I've been putting it forth to you, there's no circle geometry you cannot solve. So just follow again. Here you have here we want to prove another theorem which we call alternate segments. Alternate segments. Now here you have alternate segments. I told you about segment the other time. Now here you have a circle. Then in the circle there is a tangent. This is what you call tangent. A line that touches the circle. So if you can just label it, maybe you can label this one as PQRX. Then it alternate segment. Earlier, as I told you, we divided the segment into two equal parts. We have minor segment and major segment. Then what we want to prove is that the angle between alternate segments, they are equal. This is an angle here. Maybe you can just call this one A1. This angle here. This angle between a chord. This is a chord. Maybe you call this chord PQRX. You call this one X. We have this angle now. We want to prove that this angle is equal to any angle that the remaining parts of this the remaining part of this circumference subtend, like this. You have something like this, or you have something like this. Now you can call this one, let's call this one A2, A3. Now what do you want to prove? We want to prove that this angle here are equal to this. So what are you given? So you can say given a circle with tangent P, Q, R and chord Q, X. I see. So you have this what you are given. You are given a circle with tangent PQR and chord this. Then to prove PQRSTU, let have it like that. Then construction. What do you want to construct? Let's construct a diameter. Construct a diameter from the tangent Q joining TX. Now, what you want here is this. You want to construct a diameter here that will join this line here. So you call this one V. So then join it with this. So you construct that's a diameter from the tangent Q. This is it. And then join with X, joining X. So you simply join it with X there. Then that's it. Or you can see X or Vx. So you just simply produce this one. Now look, let's label this place. Let's call this one y1. Let's call this one y2. All right, we labeled it. Then what do you want to prove? Prove prove that the angle between a tangent, the angle between the tangent and a chord, angle between the tangent and a chord is equal to any angle subtend at any point of the remaining part of the circumference. So this is what they have to prove. Prove that the angle between a target and a chord, this is a chord, or chord is equal to any angle subtend at any part of the remaining part of the circumference. This is the remaining part of the circumference. This minor arc, minor segment and major segment. Then let's prove now. So you don't need to cram anything. It's very simple. So look, angle A plus Y. That is, you may not be like that. You can anyhow. I can say that angle RQX. That is angle RQX, which is A, plus angle SQV, angle SQV equal to 90 degrees. What's the reason here? That's perpendicular 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 uh, tangent, perpendicular line tangent to PQR. So to the tangent PQR, this is it. This perpendicular line, here you have this diameter. So you can have that one as what? Center O. So if you have a perpendicular like this, the perpendicular is perpendicular line. So this part is 90 degrees, while the other part is also 90 degrees. Therefore, what you have here is A plus Y1 equal to 90 degrees. So you have that. Again, look at another thing. Look here. This is diameter. That's so that this place is angle. This place is angle at the semicircle. We have proved that angle at the semicircle is 90 degrees. Since this is 90 degrees, it means this y1 and y2, they are equally 90 degrees. So you can say that angle xq, that's SQV, plus angle SV, SVQ equal to 90 degrees. That's complementary angle, complementary angle of angle of angle at a semicircle semicircle QVX. That's it. When you add two angles together and it give you 90, you call it complementary angle. So you can now have y1. So that's the proof. Y1 plus what? Y2 equal to 90 degree. Now look again. This is 90 degree. This is 90 degree. So 90 is equal to 90. Therefore, since 90 degree equal to 90 degree, then y1 plus y2 equal to a1 plus y1. a1 plus y1. Then look, if you take this y to the other side, you have y2 equal to a1 plus y1 minus y1. A is equal to what is this minus this is 0. So you have it like that. Now look, what we have done now is that we have shown that this angle here, this A equal to y2. And so you have proved it. And what it says that is equal to any angle in any part of the remaining circumference. So this y2, you can say that y2 equal to a3 equal to a2. So they are, and then they are what? Angle at the same segment. So angle at the same segment, we prove it before, they are equal. So we have proved it. So now let's look at this example for alternate segment. Now, what you have here is that you have a circle, then with the given angle inside it. Then they ask you to find angle x, w, x, y, z. Find angle w, x, y, and z. Now, the theorem that we finished proving, just look at it. Alternate segment. What you are looking for is a target and a chord. Then look at this. This is a target and this is a chord. Now, here is another chord and then on the target. Then you have to find the value of x. Considering this line like this triangle here, target to this place. So you know that this one here, this angle here equal to this angle. That's what we just finished proving. So you can simply put it like this, that angle SQT equal to angle QWT. Then you say alternate segment. So alternate segment. That is this angle equal to this angle. Therefore, angle SQT angle SQT. That's what is this? You have x equal to 55 degrees. That's the answer. Again, look at this one. This one, they are at the same segment. Like here, this is a chord, minor segment and major segment. This one, this angle here and this angle here, they are equal. Angle at the same segment. Or this also equal to this, as the case may be. So you can equally put it as Q, angle QV, angle QVT equal to angle QWT. See, same segment. That's angle at the same segment. So you have it like that. Therefore, this angle also Q, that's a W, equal to 55 degree. Now you have that one as 55 degree. Again, look at this angle here. Why? You have to calculate this angle. Now, what you have here is, look at this. This angle, you can get it. You got this one as 55 degree. So S is 55 degree. Look at this one. Angle on the straight line. This or this one. From here to here is 95. This is 95 here. From here to here is 90. This is 95. This is 55. Why this is Z? So you can simply put it that angle PQW plus angle WQU plus angle SQT equal to 180 degree. That's sum of angle in a triangle. So you have that. Therefore, Z plus 95 degree plus 55 degree equal to 180 degree. So that's 180 degree. Then add this together. That's 150 Z plus 150 degree equal to 180 degree. Then Z equal to 180 degree minus 55 degree. Or you collect like time. Then Z equal to 30 degree. So that's the value of Z, 30 degree. Then you've calculated X, W, Z, remain Y. Now look at this Y. This Y, look at it again. This is Z. This is a chord. Then this chord tangent to this line tangent to this. Then look at this. The angle is obtained here. Therefore, you can simply say that angle here, that is angle Q, angle PQW equal to angle QUW. That's alternate segment. Alternate segment. So Y also equal to 30 degree. So that is it. Is that simple? So that's example 1. Then look at this example 2. Now we started the theorem, the first one, second, and go. Now look at this one. I just make these questions so as to capture everything, all the theorem that we have discussed. So you follow. So you see the question I put there now, many questions, just to capture everything. So you just follow. Very simple. Just look at, when you see diagram like this, you need to open your eyes. Then let the all those theorems be in your mind. You will solve it easily. Now look, this is what we are given. Then you have to calculate all this angle. The first thing you are going to look at here is, look at this angle here. Here you have a chord of a circle. Here is tangent here. Then look, this one here is a major segment. Why this is minor segment? This chord here for major segment subtend an angle here. So this angle here equal to this angle. That is, this one is here. That is from here to here is 120 degree. From here to here is 120 degree. We subtend to this. That is, this one is equal to this. That's alternate segment. So you can simply put, I'll show you how to pick the angle. If you want to write the angle like this one now, this one is going to be what? Angle Q, angle PQC. So angle PQC is 120. Say angle PQC equal to angle QDC. So you put it there as alternate segment. That's the theory. Therefore, U, which is this, equal to 120 degree. So you are through with you. So you can move forward. Look at this, what you are seeing. This isosceles triangle. So what you will simply do is that T equal to X. That's base of isosceles triangle. Once you know that these two, they are base of isosceles triangle, they are equal. Therefore, in triangle QDC, you can have what the angle you have there is T plus U plus X. Look at it. T plus U plus X equal to 180 degree. That's sum of angle in a triangle. So you have that one as sum of angles in a triangle. Then you know T equal to X, so you can replace it. So you can write S here plus U plus this equal to 180 degree. What is value of U? U is 120. So S plus A is 2S plus 120 degree equal to 180 degree. So you collect the light term. 2S equal to 180 degree minus 120 degree. So 2S equal to 60 degree. You divide both sides by 2. This divided, that's 30 degree. Therefore, T is 30 degree, X is 30 degree. So here you have T here equal to X equal to 30 degree. So you are through with 3 out of the 10. So let's proceed. Look at it again. This angle U and this. So let me write it in normal way. Let's say that angle Q A C. Look here. This is cyclic chord. This is cyclic chord. What we are seeing looking at here is cyclic chord. So opposite angle, the sum of two opposite angles of a cyclic chord, they are equal to 180. That is, they are supplementary. So angle this plus angle C DQ equal to 180 degree. That's the sum of two opposite angles of a cyclic chord are supplementary. So they are supplementary, so they are equal to 180. So and this one is y plus 120 degree equal to 180 degree. So y equal to 180 degree minus 120 degree, y equal to 60 degree. So this place is 160 degree. So you are through with that. Again, you can pick it from here, you can pick it from here. So if you want to start from here, if you want to find the value of R, look at it again. That theorem we proved the other time. Here. This one, that is 2 times of this place. So that's what we are looking at here. Look at this chord like this. A line like this. Look at this. Look at this one like this. So you have this one like this. So that's what you are looking at. This. So this one is 2 times. Multiply this one by 2, you get this. So that is it. Now, here you have again angle QOC is equal to 2 times of angle QAC. So You put it there that angle at the center is twice the angle on the circumference. So that is it. So angle QOC equal to 2 times 60 degree. That's equal to 120 degree, which is what? Angle R. This angle R, 120 degree. Again, look at this one also. In other side, have it like that. Look here. This is the opposite of that one that look like this. Now, this angle here, 2 times of this. So multiply this one by 2, you get this. So you can equally have it like that. Isn't it? So this one, multiply this one by 2, you get this. So you can do it like that. Or you can see sum of angle at a point. You equally get it like that. So there are different ways you can do it. Now, look at this. Here, you say that angle CDQ is the angle QOC. Here you are seeing angle QOC in 2 ways. This one is obtuse angle. This one is reflex angle. So the reflex angle, this one will give you 2 times of angle QDC. So that's the angle on the circumference. Therefore, QOC equal to 2 times 120 degree. That's 240 degree. So you are true with that. Now, you got that. Here is 60. Here is 120. Here is 240 degree. Then here is 120 degree. So you are continuing. Again, now getting this. Look at another thing again. The angle here equal to the angle here. That's angle at the same segment that we proved the other time. So you can have this one as angle QAC equal to angle QBC. So you put it there that angle at the same segment. That's angle at the same segment. So angle X equal to angle Y, which is equal to 60 degree. All right. Which other one remain? Now, look here. Look at this. Here you have this. Here you have this one. This angle is a chord. Look at this. This is a chord. Subtend an angle here. So you can say that angle PQA equal to angle ACQ. Look, this is chord. This angle is subtend here, 50. So this Z. So you simply say that alternate segment. Alternate segment. That is it. So angle Z equal to 50 degree. So we are going towards it. Now, which other one remain? Done this. Now look, this angle here. Now look, here you have a straight line like this. This one you are seeing, this angle you are seeing is this is a diameter because this is center O. Since this is center O, this angle you are seeing here, this angle you are seeing here is angle at semicircle. That is angle BCQ equal to 90 degrees. That's angle at a semicircle. Angle at semicircle. Then, if this is angle at semicircle, we get C to be 60 degrees. So here a bit X rather, getting X to be 60 degrees. So you can consider that, say, you can consider triangle BCQ. This triangle BCQ. This triangle. So we want to get V. Triangle BCQ. So this alternate, since that one is 90 plus 90, so you have it there as angle BCQ plus angle CBQ plus angle BQC equal to 180 degrees. That's sum of angles in a triangle. Sum of angles in a triangle. So that's it. So X, angle B, angle C is 90 degrees, angle B is 60 degrees plus V equal to 180 degrees. So here you have 150 degrees plus V equal to 180 degrees. Then V equal to 180 degrees minus 150 degrees. V equal to 30 degrees. So that's it. Which other one again? Okay, look, the main W. Now, we want to calculate W. Here, we get this one as 30 degrees. Now, we want to calculate this. Look at this. Z. This Z, we say is 50 degrees. Z is 50 degrees. So, the angle here is 120 degrees. Here, the angle here is 120 degrees. So why this one is 30? So to get this place, you can simply say angle on a straight line. So we have, that is angle PQC, angle PQC plus angle this one, that is CQD. That is this angle 30 plus angle Q plus angle P, that's angle DQR. This one, that's 180 degrees. That's sum of angles on a straight line. So angle Q, you have 120 degrees plus 30 degrees plus W equal to 180 degrees. So 150 degrees plus this equal to 180 degrees. So W equal to 180 degrees minus 150 degrees. That's 30 degrees. So this place also is 30 degrees. So which other parts that we have not done? So you can see that angle Q is 240 degrees, angle R is 120 degrees, angle X is 30 degrees, T is 30 degrees, U is 120 degrees, V is 30 degrees, W is 30 degrees, X is 60 degrees, Y is 60 degrees, Z is 50 degrees. So we are through with it. If you have any question regarding this, you can simply put it in the comment section. We attend to it. Or any other question that you see there, maybe you are trying to solve that you can't solve, just let me see. So uh,